So in this unit, we're going to be talking a lot about area, perimeter, and volume of different shapes. And let's just review for a minute the formulas that you've learned in past grades, because we're going to need to build on those in our lessons. And so we've got some of the basic shapes here that you've seen before. We've got the square, rectangle, triangle, and a circle. And you should have, in previous grades, being able to calculate the perimeter and area of all four of these shapes. So let's just remind ourselves what the formula is. If we have a square, generally they'll mark a square by putting a tick on all four sides to show you that all four sides are equal. And so we can call the side length S, or we can call it length or width, whatever you want. But the perimeter is just the distance as you're traveling all the way around the outside edges of the shape. And so we would just be traveling S plus S plus S plus S. And I just realized that looks a lot like a 5, doesn't it? It should be an S. So 4 times S, or 4 times L, or whatever you want to call that side length. If we're finding the area of a square, the area of any rectangle, and a square is a specific type of rectangle, is just length times width. In the case of a square, it means that we just have length times length because it's the same. And we can write that as L squared if we want to get fancy now that we have our exponents as well. And so for a rectangle, we do have two different side lengths. Usually we call the smaller one width and the larger one length. I'm just using cursive letters for my L there. That's why it looks funny. And so if I was traveling all around the outside of my rectangle, I would do a W plus an L plus another W plus another L. And that's just 2 W's and 2 L's. We collect up the like terms there. And the area of a rectangle is the same as a square. We just do length times width, and that's it. And so for a rectangle, we're going to have a different length and width, and that's why we need both letters this time. Now, I don't know if you've thought about this before, but a triangle is really half of a rectangle. Like if I make a rectangle and I put a diagonal through it, then I've made 2 triangles, and each one of those triangles has half the area of the previous rectangle. And so we're just going to work off of that formula when it comes to the area of a triangle. We would write area equals length times width, but it's only half, so for half of something we just divide by 2. For the perimeter, I would need to know all 3 sides of my triangle, and the perimeter of that triangle is just A plus B plus C. And then the last shape that we have here is our circle. And for a circle, we're generally given either the radius or the diameter. If we're given the radius and we're asked the perimeter of a circle, the perimeter of a circle has a different name. It's called circumference. And so instead of P, we write C, but it means the same thing. Circumference just means the distance all the way around the outside of the circle. And so the circumference is 2 times pi times r, or there's another formula if they give you the diameter, which is all the way across, and in that case we would just do pi times diameter, since diameter is 2 of the radii. And pi, remember, is just that crazy number that goes on forever and ever, and we shorten it to 3.14 for all of our needs in high school math. Now, if we need to find the area of the circle is that pi number again, 3.14, times the radius, or times r squared. And so that would give us 3.14 multiplied by the radius once, and then multiplied by the radius again. And those formulas should come back to you, but I would say on your second box on your notes page for this unit that you should include all of these formulas on that page. Now, since we've already done perimeter and area of those basic shapes, what we're going to do in grade 9, just to move it up a level, is we're going to take 2 or more of those shapes and combine them, and we're going to try to use the formulas for both to find the perimeter and area of those shapes. So what I have here is a rectangle with a little bit of a bite taken out of it, and that bite is in the shape of a semicircle. If it was just a rectangle, then I would have 3.1 and 5.4 as my sides, and I could find the perimeter in the area. But I've got this part that has been removed from that, so the area is going to be less than it was before we took that half a circle out. And the perimeter is going to change also. The perimeter is actually going to be larger, because if we put this arced curved sort of side in there, that's actually going to be longer than the straight side that we have on the other side. So let's take a look at this. I think area is probably the easier one. If I take my rectangle, and then I recognize that the other shape that I have here is a semicircle or half a circle with the diameter equal to 3.1, then my radius is going to be half of that, so that's going to be 1.55. And so if I find the area of the rectangle, I'm just going to multiply 3.1 times 5.4. That gives me 16.74, but we know that's too much for the area because there's a little bite out of it, and that little bite is in the shape of our semicircle. So the area of our semicircle, we're going to use pi r squared here, so 3.14 times 1.55 squared. And then we're going to divide that by 2 because it's only half a circle. On my calculator, I get 2.43. We'll just go to 2 decimal places there. And so that's also in centimeters squared. And if I want to know the total area, we know that's going to be less than what we got for the rectangle. We're going to take 16.74 centimeters squared, and we're going to subtract 2.43 centimeters squared from that. And that's going to give us our resulting area. And so we get 14.31 centimeters squared. So that answers the question for the area. Now, if I want to answer the same question for the perimeter of this shape, then I can start out by just adding up the straight sides that I have. So I have 3.1 centimeters, 5.4 centimeters, and another 5.4 centimeters on the bottom. And then I'm going to put a question mark because I don't know the length of this arc that has been drawn on that side. And so let's think about that for a minute. I'm going to just figure out the length of that question mark, and that should be 1/2 of the circumference of my circle. And so remember, if I have the diameter, which is 3.1, because that's all the way across, is 3.1, then the formula for circumference is 3.14 times d, which is 3.1. But it's only half a circle, so we're going to divide by 2. So that will give us the arc length, or the distance on the edge of that circle that's being taken out of our rectangle. And I get 4.87 rounded off for that value, and that's in centimeters. And so now I can take my perimeter and I can say 3.1 plus 5.4 plus 5.4 plus 4.87. When I add all of those up, then I'm going to have the total perimeter of this shape. That's going to give me a total perimeter of 18.77 centimeters. And so that's my final answer for the perimeter of this unusual rectangle with a little bite taken out of it. All right, so in our second example, we have what looks like sort of a house. It's a rectangle with a triangle on top, or you could look at it as 2 rectangles with 2 triangles on top. Whatever way you see it is fine. And you see that we got a couple of hash marks there, so that tells us those sides are equal in length, and if we know it's 4 centimeters across the bottom, then each of these has to be 2 centimeters, and that might help us later on. And then we know 5 centimeters for the length of this side, and so we're going to assume 5 centimeters here as well. That should have been written on. And the thing that we don't know, we know this distance, which is the altitude or the height of our triangle, but what we don't know is these slanted lines. And that's why we started with Pythagorean theorem in this unit, because we have a formula for being able to find that value. Let's call it x here. We know that x squared is equal to 2 squared plus 1 squared. So x squared is equal to 4 plus 1. X squared is equal to 5. So x is equal to the square root of 5. And if you want to, you can just do that as a decimal on your calculator. And I'm going to get 2.24 approximately, and that's okay for now. So that means that each of these slant sides is 2.24 centimeters. And so all of this setting up, I think, is really important because it's going to help us just dive in and find the perimeter and the area. Let's start with the perimeter. All we have to do is walk around the outside of this structure, of this shape, and add up the sides as we go. So if I start on the bottom, I have 4 centimeters, then I have 5 centimeters, and then I have 2.24 centimeters, then I have 2.24 centimeters again, and then I have 5 centimeters. Okay, we don't add any of the inside lines. The perimeter is always the distance around the outside. So if we add those up, we're going to get 10, 14, 16, 18.48 centimeters, and that's the perimeter of our shape. And so now we want to find the area of our shape, so let's switch colors. And the area of our shape is just the area of our rectangle plus the area of our triangle. So the area of the rectangle is going to be length times width, which is 4 centimeters times 5 centimeters. And then the area of our triangle is going to be base times height, so 4 centimeters times 1 centimeter. And then we have to divide by 2, remember, because the formula for triangle is always half of a rectangle. So I put the two chunks in brackets. So this one here is the rectangle and this one here is the triangle. And all we need to do is calculate those together and add them, and then we have the area of the whole shape. And so 4 times 1 divided by 2 is 2 centimeters squared for the triangle, and this diagram is not drawn to scale. And so we have 22 centimeters squared for the total area of this shape. In this last example, we've got 3 different shapes that are put together. That's what composite means. It means like the combination of things. So we're combining a semicircle or half circle, a rectangle, and a triangle, and we want the perimeter. No, we don't want the perimeter. We just want the area, so that's even going to be easier. And just like before, let's have a look at what we're dealing with before we start and just make sure we have all the dimensions that we need to find the areas. So the height of our triangle is going to be the same as the height of our rectangle, which is 6 inches. It's the base of the triangle here that we also need. So if we have 14 from here to here and 10 from here to here, then this must be 4 inches. So now we have the base and the height. Sorry, I put an M there instead of an N. So we have the diameter of our semicircle. So this is a half a circle. And we have the length and width of our rectangle. And we have the base times the height of our triangle. So we have everything we need. So let's do it one piece at a time, and then we're going to add it all together. So the area of our half circle, or semicircle, remember it's pi r squared, and so the radius has to be 3 if the diameter is 6. And so we're going to do 3.14 for pi times r squared, which is 3 times 3, and that's going to give us the area of our circle. So the area of our circle Oh, sorry, that's a half circle. We have to divide that by 2. All right, so our half circle area is 14.13 inches squared. So let's change colors, and now let's work on our rectangle. So the area of the rectangle, and that's just length times width, so that's easy. That's just 14 inches times 10 inches, and that's 100, oh, I'm sorry, times 6 inches. Looking at, it's the 14 that's wrong. My apologies. All right, so we're looking at 10 inches for the length and 6 inches for the height. So that's 60 inches squared for the area of the rectangle. So now let's have a look at our triangle. I'll just draw a little triangle down here, and we're going to do length times width, so 6 times 4, and then we're going to divide by 2 because it's only half of the rectangle that would have the length and width of 4 times 6. And so that's going to be 12 inches squared. And so for our composite area, we're just going to do area total, and we have 14.13 square inches for the half a circle. We have 60 square inches for the rectangle, and we have 12 square inches for the triangle. And if we add those all together, we have 86.13 square inches for the total area of this composite figure. I think a couple of examples, especially including a circle as part of the figure, would be a really good idea in your notes section for today's lesson. And then there are questions on the worksheet with answers that you can try to make sure that you're understanding this correctly.